Hi there, this is Imran Shaikh, and today I am going to present my research report presentation. The research title is Top and Nearest Neighborhood Based Movie Recommendation System Using Different Recommendation Techniques. So there is an abstract section. The abstract of this research is based on 3 brief steps: background overview, objective and results. Recommendation engines are extremely common and utilized by many tech giants like Facebook, Google, IMDb, Netflix, financial services, and many other companies. Recommender system is a core machine learning approach for revenue generation as well. The main aim of this research is to build a recommender system that will recommend movies to the user not only by predicting rating but also on the similarity basis of similar user and their interested items. The best RMSE accuracy score result is achieved with SVDPT algorithm by implementing it on matrix factorization recommendation technique, and the final accuracy mean of the model was almost 88% RMSE and 66% MAE score from k-fold cross-validator. In the introduction section is divided into three. The introduction section is divided into 3 sections: overview, background, motivation, and objective of the research. The main industrial application have implemented the recommender system approach in sectors like e-commerce, social media, movies, sound streaming, and etc. Big tech giants like Facebook, YouTube, IMDb, Instagram are facilitating their companies business growth by improving the recommendation system algorithm to give user the best recommendation results. Recommendation systems mainly comprises of 2 basic types: content-based filtering and collaborative filtering. The main aim of this research is targeted towards the domain of education sector. It is a small scale project which has utilized different recommendation system techniques by testing various models' accuracy to present best possible result to the user. The motivation of this research is to understand the behavior of the recommendation system by implementing various techniques and machine learning models. Netflix is one of the biggest industries which has implemented recommendation system and improved it constantly for their business revenue generation. 5 models have been implemented, that is KNN baseline, KNN with means, user base and collaborative filtering, SVD singular value decomposition, SVD plus singular value decomposition plus, and 2 cross validation techniques have been utilized for model evaluations, that is k-fold cross validation and Lee-Fanov cross validation. In terms of research question, the research question stated that how can we recommend top and good recommended movies according to the user's interest by using nearest neighborhood based recommendation systems, techniques, and machine learning models. So in the section of methodology for this research project, CRISP-DM cross-industry standard process for data mining is utilized as a methodology approach. It contains a business approach as well. The recommendation system are extremely common and utilized by many tech giants like Facebook, Google, IMDb, Netflix, financial services, and many other companies. The data extraction part consists of almost 100k ratings by different users with over 1200 movie tags from 9125 movies. The data set is collected and generated by Group Lens research group. Data set is publicly available on Group Lens website for machine learning and recommendation system application purpose. The data analysis and preparation on movie lens data set involves steps of data cleaning by checking null values, merging of data table, movies and ratings, on movies IDs as an inner join describing column removal of unnecessary features. A separate function which counts words is created to remove the pipes and separate genre from each single cell. And there are many data visualization plots plotted which illustrates the most popular movies genre and the rating counts for each movie title and top 25 movies with highest rating are plotted as well. For model implementation phase, the models are used in our recommendation system are KNN baseline with similarity matrix of Pearson baseline. For content-based filtering technique, KNN means for user item is collaborative filtering with cosine similarity and matrix factorization use. Support value decomposition and support value decomposition plus algorithm for top n movies recommendation to the user. In the design specific phase, we have proposed three architectures. One is content-based filtering, and there is memory-based collaborative filtering, and the third one is matrix factorization. In content-based filtering, the recommended system focus on attributes of item, in our case genres and years of the movies, by finding similarities of those items attributes which each user liked to provide recommendation at the end. The process start measuring content-based similarities between the attributes of the movies and the user rating. Then our nearest neighborhood algorithm will sort out top 10 nearest neighbor to the movies by finding those neighbors with highest similarity score and turn them into actual prediction by computing weighted average. The proposed memory-based collaborative filtering further divided into two more types: the user-based collaborative filtering and item-based collaborative filtering. Both collaborative filtering are shown in the above architecture. The step involved in user-based collaborative filtering are user item weighted matrix, user similarity matrix, candidate generation, candidate ranking, and filter out already watched items by specific users and recommend top 10 nearest movies recommendation which he hasn't watched yet. And for the item-based collaborative filtering is same like user-based collaborative filtering by just replacing user similarity matrix with item similarity matrix. The proposed matrix factorization, which is our third implementation, is also known as model-based collaborative filtering technique, one of the useful techniques in recommendation system. Here R is our matrix factorization matrix, which is equal to dot product of two matrices, which is U and MT. Here U and MT are typical users and movies matrix. So by taking dot product of a typical user matrix and typical movie matrix and getting for every combination of users and items, latent features are then gathered with the dot product in our matrix factorization matrix, through which prediction of a rating for a specific user and item is possible to recommend top n movies as a final result. In implementation phase, the steps involved are data collection, data analysis and pre-processing, recommendation techniques with machine learning algorithms, model hyperparameters, tuning and evaluation. All coding is done in Python programming language using Jupyter Notebook as an IDE. Data collection and data analysis and pre-processing already explained in methodology section. So here we will discuss recommendation techniques and machine learning models implementation. So for three recommendation system techniques which have been implemented in our recommendation engine. Nearest neighborhood content based filtering technique, nearest neighborhood user item collaborative filtering technique, and matrix factorization technique. A separate movie lens data class is created to utilize it in our proposed recommendation technique. The movies lens class loads both movies and rating dataset, and to define relative functions or methods. Nearest neighborhood based content based filtering technique recommend top 10 movies as a result. These movies are based on similar genre and similar year to the movies which each user liked. So here we have used the KNN baseline machine learning algorithm with similarity metric of Pearson baseline for resulting top 10 nearest neighborhood, top 10 nearest neighbors for the specific movie. So in collaborative filtering technique, as we have discussed that memory based filtering technique is divided into two parts, that is user based collaborative filtering and item based collaborative filtering. So here the process involved that first we are loading up our data from our movie lens class which we have created and preparing and test. That loaded data initiate our k-means algorithm along with quotient similarity measure, it compute similarities, and start the process by building and lookup table of users to all of the items they have rated, and by finding those items and user system builds 2D matrix of the similarity scores between each pair of the users. Finally, filtering out the already watched item, we recommend top 10 nearest neighbor movies resulting for specific user. In our implementation of a matrix factorization, a user movie matrix is created, and with using support singular value decomposition and singular value decomposition plus algorithm that works on PC principle. So by taking dot product of the associated rows in typical user matrix or for user and associated columns for the items and recommending top 10 movies accordingly. Models hyperparameter tuning section is a process of search best parameters for the models to obtain best optimal results. For the hyperparameter tuning of our recommendation engine, we have considered grid search CV technique to find best parameters for the model. The evaluation part consists of next part is evaluation part. It consists of the for the evaluation purpose, the accuracy values of different machine learning models are validated with two cross validation techniques, k-fold cross validator and leave-one-out cross validator, and two accuracy measures, root mean square error and mean absolute error, are utilized for evaluation purposes. 5 machine learning algorithms, KNN baseline, KNN with mean for user-based collaborative filtering, KNN with mean for item-based collaborative filtering, and SVD algorithm, SVD-PP for checking the accuracy, have been validated with 3 folds from each validator. K-fold cross-validation mean accuracy, mean results of the model used in our recommendation system. The lower value of RMSE are considered to be good. The best RMSE and MAE scores attained by SVD-PP used in matrix factorization technique, that is 88% RMSE and 66% MAE, followed by KNN baseline, SVD, KNN with mean, and KNN with mean UB. Leave-one-out cross validator shows the mean accuracy results of the model. Here in this figure, the best RMSE and ME scores are obtained by SVDPP in matrix factorization technique and KNN baseline content based filtering technique, that is 91% RMSE and 69% ME for support vector for singular value decomposition plus algorithm, followed by support vector decomposition algorithm, KNN based with means for item based collaborative filtering, and KNN with means for user based collaborative filtering. But comparatively, K4 cross-validation folds results are 2% more accurate in comparison to leave one out cross-validator. So finally, the conclusion and the future work is here. Implementing different recommendation techniques along with machine learning models on our recommendation engine, it is found and concluded that best results of RMSE is 88% and ME 66% scores. Measures is attained by support vector plus algorithm, which is used in our matrix factorization techniques, and the evaluation cross-validator was K4 cross-validation. Problems like data sparsity, cold start problem, stop list, random exploration, filter bubble, trust and outliers are real-world recommendation system challenges. For the future improvement in this recommendation engine, implementation of deep learning model, restricted Boltzmann machine and auto encoder from deep learning area can be implemented, and moreover hybrid filtering technique and increment on number of iterations on different recommendation machine learning models for better results accuracy. Thank you for the presentation. So coming to the section of data demonstration, here we have Jupyter Notebook 5. We have coded for that movie lens dataset analysis. So here we imported libraries, take the head of it, and do the data pre-processing, defining ratings, cleaning data, analysis and data processing of each data, merging ratings and movies table based on movies ID with inner join. Moreover, we have presented the low rated movies or high rated movies, and so here we have top 25 most rated movies, and here are the movies with their years and titles. So here the interesting part is the creation of a function that counts number of times of each genre appears, and so here we can count the number of occurrence of each genre, like for drama, which is almost 4365 times repeated for different movies. So for the visualization purpose, we are considering word cloud, histogram, and the bar charts, which represent top 25 highest rated movies. So here in nearest neighborhood based content recommender system, we are using KNN baseline algorithm. So here we are importing libraries. We have created function to read the item names from the movies, loaded the data, split training and test set, user Pearson baseline as a similarity matrix in KNN baseline algorithm. Here the similarity matrix is Pearson baseline, and the k value is 30. So here we are mapping the raw IDs into the movie's name, fetching the inner ID of the movie. Multiple movies can be selected to check the top and nearest movies result. Like here we have used Braveheart you can change it to Forrest Gump or Toy Story to check the results at the end. And finally we are getting output of 10 nearest neighbors by content based filtering. And the cross validations results of RMSE and ME fit time, their test time, and then the conversion of the cross validation results in data frame. So now here we come for collaborative filtering technique, which is also called memory based collaborative filtering. So here we have distributed, we have used two types of collaborative filtering, user and item based collaborative filtering. For that we have imported libraries, created a separate movie class to fetch data and to define relative variables to it. So here are the rating path for extracting the rating CSV file from the directory, and so you can change the directory here for the rating and movies part. And here we are loading our data set. So this function is actually creating a ratings dataset in the format of user, item, ratings and timestamp, and this function gets the movies from their movies IDs, movie names from their movie IDs. So here we are loading the dataset and define the movie lens class, we are calling that. And so here is the implementation of the similarity option for our KNN with means model. So we are using a similarity matrix of cosine here, and fitting the model with the train set, which we have split it over here, and getting in the description we have defined in our design specification implementation, and we are getting top and similar users to our test subject. The test subject is user 85. Here you can change any of the users like 1, 10, or any user ID can be defined here. And these are the top and nearest neighbors. And so then after getting the top 10 similar users, we are getting the staff they have rating, the users have rated, and add up their rating for each item weighted by user similarities. After that we are creating a dictionary of stuff the user has already seen, because we are not recommending movies which are already seen by the similar user, which is watching movies with interest. So here we are recommending movies which is not watched by that particular user yet, and find the movies from his top 10 neighbors. So at the end we are getting top 10 items from the similar user, from the similar users, and here are the results. Same for the item based collaborative filtering, but here in the similarity option we are changing user base to the false, and the same process will happen. We can change the user ID here, the candidate generation, already watched items, and already watched items which already watched item will not recommend to the user. So here at the end we are sorting the movies which are not watched by the user actually. In the matrix factorization, we are training our set and defining the SPD model, fitting the SPD model as well. You can change the user, define user here, and finally getting the matrix factorization results with SPD for user 85. Same process will happen for support vector plus singular value decomposition plus algorithm implementation on matrix factorization. So here you can get top 10 recommendation results with that model, and at the end we have cross-validated with five cross-validations. So the maximum accuracy, I think the good accuracy is 0.88, mean it's 88%. The lower is the better result. So here is the hyperparameter tuning section of the report. Here what we are doing is getting the best parameters for our models by using grid search CV algorithm. So here the same process, loading libraries, loading data, training and testing data using search CV for algorithms tuning. For content based filtering we are using KNN baseline, and here are the parameters which we have defined for KNN baseline algorithm, but here we are searching best parameters for this algorithm with the help of grid search cross-validator. So here are the implementations, and it finds all these parameters and the best RMSE score. Everything is defined at the end. The same happens with the collaborative filtering. The models used in the user-based collaborative filtering with the parameters are defined here. Item-based collaborative filtering, same performance for same coding, same parameter setting for both, I think. Yeah, it is. Matrix factorization, we are using SVD algorithm and support and SVD++ algorithm. So we define its parameters as well to get the best recommendation results at the end. So here is the implementation and the best parameters get from grid search CV. So in model evaluation section, for the model evaluation purpose, the accuracy values of different machine learning models are validated with two cross-validation techniques, that is k-fold cross-validation and leave one out cross-validation. Two accuracy measures, that is root mean square error and mean absolute error, are utilized for evaluation purpose. 5 machine learning algorithms, KNN baseline, KNN with means for user based, and KNN with means for item based. So singular value decomposition and singular value decomposition plus for matrix factorization. To check the accuracies, it is validated with 3-fold from each validator. So here we are importing libraries, loading dataset, using k-fold cross validator, checking the accuracy with the accuracy measure RMSE and MAE. So here are the results from all the models. We are visualizing the evaluation results as well. It's 3k-fold model accuracy results. So taking evaluation of models with k-fold, there are 3 folds involved in this graph for each model, and we check the mean accuracy. Best accuracy is attained by the SVD++ algorithm with 88% RMSE and 66% MAE, and while implementing leave one clause validation, the visualization results of the models of leave one out cross validator shows the percentage of, I think, the best RMSE score is gained by our SVD++ algorithm, which is 90% RMSE and 68% MAE, mean absolute error. Here these are visualization plots as well, through which you can hover and getting the accuracy values. So the mean accuracy, this is the best mean accuracy from the SVD++ model, which is used in our matrix factorization. So thank you for listening, and I hope you like the presentation.